Now we're going to look at how to solve trig equations when it's included or when it's factorable or has factors. So if we look here, this would be similar to if we had x minus 1 times x plus 1. So when we solve this equation, remember that we set each factor equal to 0. And then we solve. So here we would add 1, and then here we would subtract 1. Right. So our process is very similar. So we're going to set this thing equal to 0, and then this thing equal to 0. So each factor equal to 0. So tangent of x minus 1 equals 0, and cosine of x plus 1 equals 0. And we solve in the same manner that we did over here, where we're going to isolate the trig function in this case. So we have the tangent of x equals 1. And then here we subtract 1 so that the cosine of x is by itself. So now this looks like our equations from the other day. Well, if I want the tangent to be 1, that means I need the x and the y values to be matching. Well, they're matching at 45 degrees. Notice in our instructions that we're solving from 0 to 2 pi. So if it's 0 or 2 pi, you're going to pick 0 since it's got the bracket and not 2 pi since it has the parenthesis. So in our tangent, we've got all students take calculus. So the tangent is positive in the first and the third quadrant. So we want our 45-degree reference angle, which in radians is pi fourths, in our first quadrant, which is just pi fourths. And then we also want the pi fourths reference angle that's in the third quadrant. So then that gives us 5 pi fourths. Well, that's the answer just to this part. So now I need to come over here and solve this part. Well, if we want the cosine to be -1, hopefully you recognize that that is going to be one of our axis points. So I'm thinking, okay, well, if we've got these 4 points, this is 1, 0, -1, 0, 0, 1, 0, -1. The cosine's the x value. Well, I want where the x is -1. So it's not this one, not this one. This one works, this one doesn't. So we only have one answer here, and that's where pi is located. So not 5, pi. So we've got all three of these as answers to this equation. Okay, remember we're solving on the interval from 0 to 2 pi, so I don't need to do plus 2 pi k because we just want these ones that are between 0 and 2 pi. Okay. So pause the video and try this one. Okay, so on this one you're going to set each factor equal to 0, right? So you should have tried this one. That's a skill set that you should be working on, is to pause videos and try things. So here we're going to subtract root 3. So we get 2 cosine x equals -√3. So I divide by 2. So cosine of x is -√3 over 2. Here I'm going to subtract 1. So 2 sine x equals -1. And then we divide by 2. So sine of x is -1/2. Now, if you can get to here and here, just using your algebra skills in your head, then that's fine. Right? So now we need to solve both of these equations here. Well, I want the cosine to be √3 over 2. Well, if the cosine is √3 over 2, you can either think in terms of your hand trick or you can think of your triangle, right? So if this is your triangle, you want the cosine to be √3 over 2. So that would be this is √3 and this is 2. Okay? So that means that this is 1. Across from the 1 is the 30-degree reference angle. Or you can say, okay, well, for the hand trick, I need 3 fingers on the left side. Well, if I have 3 fingers on the left side, then that means that my index finger is down, which means that it's 30 degrees, which is our reference angle, but in radians, that's pi 6. So now we think, okay, well, all students take calculus. This cosine value is negative, so our cosine's positive in these 2 quadrants, which means that it's negative in these 2 quadrants. So I want where, I'm going to come up here and put my answers. Okay. We want where the pi 6 reference angle in the second and third quadrant. So that gives us 5 pi 6 and 7 pi 6. Wow, that was horrible. 7 pi 6. Okay. So that's the answers from cosine, but now we also need the answers from sine. So for sine, you're thinking, okay, well, if I draw a picture here, we've got The sine would be opposite over hypotenuse, so this would be 30 degrees as well. So the 30 degrees is pi 6. Okay. So then we have that all students take calculus. So the sine is a negative value, so our sine's positive in these two quadrants, which means that it's negative in these two quadrants. So I want the pi 6th reference angle that's in the third and the fourth quadrant. Well, the third quadrant is 7 pi 6. We already have 7 pi 6 from this one over here. I do not need to duplicate it. So then I can just move on to the fourth quadrant, which is 11 pi 6. So these three answers work to get us to 0. Okay. So if we look at this one, again, it's already factored for us, so we're going to set each factor equal to 0. So we're going to do the cotangent of x equals 0, and then the tangent of x minus 1 equals 0. So here we can add the 1, so the tangent of x is 1. Okay. Well, if the tangent of x is 1, that means I want the x and the y values to be matching, which is at 45 degrees, or root 2 over 2, root 2 over 2. Or if you're thinking in terms of your triangle, you need both of the legs to match so that you'll get the same value. So then this would be 45 degrees. So we're still in radians. So we have all students take calculus. The tangent is positive in the first and the third quadrant. So I want pi 4ths reference angles from the first and the third quadrant. So that's pi 4ths and 5 pi 4ths. If we look at this one, the cotangent of 0, remember that 0 is really over 1. So this would be our x value, this would be our y value. So, okay, if we look at, it's not going to be one of our 30, 60, 90, 45, 45, 90 ones. So I'm going to say, okay, well, this is 1, 0, negative 1, 0, 0, 1, 0, negative 1. Okay. So if I want this to be the x over the y, I want the 0 to be in the x spot. So 0 over 1 or 0 over negative 1. Both of those would give me 0. 0 over negative 1 would just still be 0. So both of these values work. So straight up is pi halves, and straight down is 3 pi halves. So then these four are our answers. Okay. Now, if we look at this one, this would be similar to a question like x plus 2xy equals 0. Right? So this has a common factor of x, so we would take out the x. So if we take out the x, that would give us 1 plus 2y equals 0. Right? So we're doing that same kind of thing here, where we have a common factor because there's a sign in both of these terms. Okay? I'm going to erase this part. Whoops. So if we take out our greatest common factor of sine, we're going to do sine of x divided by sine of x, which is 1. And then 2 sine x cosine x divided by sine x will leave us with 2 cosine x. So that means we set each factor equal to 0. So now it looks like our previous 3 problems. And then when I set this one equal to 0, if you can see that you subtract the 1 and divide by 2, you can just skip to cosine of x is negative 1/2. Okay. So our sine of 0 is going to be on our axes. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay. So the sine is 0. Remember that the sine is our y value. So I want where the y value is 0. Well, our y value is 0 at these two spots. So we're going to pick 0 and pi. I'm going to go look up here. Between 0 and 2 pi, I'm picking 0 because it's equal to 0 but not equal to 2 pi. So we get x is 0 and pi. And then where the cosine is 1/2, you can think, okay, well, that means I want 1 finger on the left, which means I have, not 4 fingers. There we go, 3 fingers on the right. So then that gives us that that's 60 degrees, which is pi thirds. We have all students take calculus. Our cosine is negative. It's positive in the first 2 quadrants, so that means it's negative in the second and the third quadrant. So then I want my pi thirds reference angle that's in the second and the third quadrant. So then that would be 2 pi thirds and 4 pi thirds. And then this gives us our answers here. Now on this one, some of you may be tempted to divide by a tangent squared. You don't want to divide by a tangent squared because you'll drop some answers or some possible answers. So instead, we want to move this to the other side. So it'd be similar to if we did x squared y equals x squared. So I would subtract the x squared to the other side. Okay. So I'm going to subtract the tangent squared to the other side. So instead of dividing, you want to add or subtract so that the function still is there and it's not disappearing or canceling out. If you cancel it out, what happens is that you'll get some answers, but you potentially won't get all of the answers. So notice this has a common factor of tangent squared. So if I take out the tangent squared, of x, that gives us cosine of x minus 1 equals 0. Right? Because tangent squared cosine divided by tangent squared is cosine. Tangent squared divided by tangent squared is 1, and now I keep the minus sign. So now we're going to set each factor equal to 0. Well, that gives us tangent squared equals 0, and then cosine of x minus 1 equals 0. Well, we don't want tangent squared, we want tangent, so I'm going to do square root of both sides. So that gives me the tangent of x equals plus or minus the square root of 0, which is just 0. And then 0 doesn't have a plus or minus, so it can really just be 0. Okay. Here we add the 1 to the other side, so our cosine equals 1. Well, if our tangent is 0, remember that's really over 1, so this is our y and this is our x value, so that's going to be our axis point. So if we want our y value of 0, that means I want so that I'm not moving up or down at all. So that would be these 2 points here. Notice we go 1, 0, negative 1, 0. So if I do y over x or y over x, I'll get to 0 on both of these. So we have x equals 0 and pi. Again, I'm using 0 instead of 2 pi because of how the instructions are worded, that we're going from the interval bracket 0 to 2 pi infinity. 2 pi parenthesis. There we go. So our cosine is equaling 1. That means we want our x value to be 1. Well, that means, again, we're going to be on the axes. So 1, 0, 0, negative 1, 0, 0, 1, 0, negative 1. So the cosine is the x value, so I'm looking at the x value being 1. Well, here our x value is 1. No, no, because this is negative 1. No. So this is our only answer, so then we get x equals 0, but 0 is a duplicate of this one, so you can just box that one as your answer. Now on this one, notice this is a trinomial, so we have 3 terms. Whereas before, here we had 1 term on this side, 1 term on this side, 1 term, 2 terms, right? This one is a trinomial. Notice this one is squared, this one is not, and then a number. So this is similar to your 2x squared plus 3x minus 1. Okay. So here we would want to multiply to negative 2 but add to 3. Okay. Oh, excuse me. That's not going to work. Unless my brain is too tired to see something, that would be 2 and 1. Yeah. That is my error. So let's change this to a plus. Okay, now it'll work. Okay, change that to a plus. So if we're trying to multiply to 2 but add to 3, we need 2 and 1, which multiplies to 2 but adds to 3. You can pay back the 2, so then you get 1 and 1. So then this would be x plus 1, 2x plus 1. Oops, sorry. Now, we're going to do that same kind of thing with here, but in place of our x, we're thinking, okay, the x will just be replaced with cosine. So we still want to multiply to 2, but add to 3. So then this would be 2 cosine, cosine. You can do guess and check as well, so this would be 2 cosine squared. We need to multiply to 1. The only way to multiply to 1 is 1 and 1. So then I'm going to check these two terms. This gives me 1, this gives me 2. I'm trying to get to 3, so I need both of those to be positive. So plus, plus. So, oh, I dropped an x there. Let's not do that. So then I set each term, each factor equal to 0. So here, this gives us cosine of x is negative 1/2. And then this one gives us cosine of x is negative 1. Because we know all students take calculus and the cosine's negative, we know it's positive in these two, so it's negative in these two. So I want in the second and the third quadrant. Well, that means we want where we've got one finger on the left side, which gives us that this is 60 degrees, which goes with pi thirds. So then the pi thirds in the second quadrant is 2 pi thirds. The pi thirds in the third quadrant is 4 pi thirds. Now, with cosine being negative 1, that's going to be on our axis point. I want where the x is negative 1. So that means I'm going left by 1. So that would be this point here. You can check your other ones and make sure that they don't work. Right? So cosine being our x value, I want the x to be left by 1. So that's just at pi. So x equals pi. So then these three are our answers for this equation.